This is Math 6, Lesson 4-2, Exponents. An exponent tells you how many times a number or base is used as a factor. A base is when a number is written in exponential form. The number that is used as a factor is the base. And a power is a number that can be expressed using an exponent. Now, it's really easy to get these confused, so let me give you an example. For example, 625 can be written as 5 times 5 times 5 times 5 times 5. The 5s that you see here are your factors. In exponential form, that can be written as 5 to the 4th, where the 5 here is the base, and the 4 is the exponent. Okay, the 4 tells us how many times we're going to use 5 and multiply it by itself. Using an exponent. One of the things that you have to be able to do is understand how exponents work. The easiest way to do that is to be able to convert back and forth between something that's in what we call exponential form and something that is in factored form. The numbers you see here are in what we call factored form. They're a bunch of numbers multiplied together, which means they are factors. 6 times 6 times 6, 2 times 3, 2.3 times 2.3, x times x times x times x. To write them in exponential form, we just simply need to tell ourselves how many times the base is being used as a factor. I have 3 6's here, so this is 6 to the 3rd power. I have 2 2.3's here, so this is 2.3 to the 2nd power. I have a tendency when I have decimals to put the entire decimal number in parentheses before I apply my exponent, so that we don't think that that is 2 and 3, even though it shouldn't be, but people get that confused. I like to put my decimals in parentheses before I apply the exponent. I just think it's easier to read. I happen to have 4 x's here, so this would be x to the 4th power. So writing things in exponential form is actually very simple. You just have to count up how many times the base is being used. Simplifying a power. When you simplify a power, that means you're going to multiply it out all the way, which means you have to remember that this 6 to the 3rd means 6 times 6 times 6. It does not mean 6 times 3. It means take 6 and multiply it by itself a total of 3 times. Well, I know that 6 times 6 is 36, so I simply need to take 36 and multiply it by 6. 6 times 6 is 36, 6 times 3 is 18, plus 3 is 21, so I have 216. So 6 times 6 times 6 is 216. Therefore, simplifying 6 to the 3rd is 216. 3 to the 5th means I'm taking 3 and multiplying it to itself a total of 5 times. 3 times 3 times 3 times 3 times 3. Now remember, multiplication is commutative, which means I can multiply in any order I want. It's also associative, which means I can group it in any way that I want. I know that 3 times 3 times 3 is 27, because 3 times 3 is 9, and 9 times 3 is 27. I know that 3 times 3 is 9. So I'm now just going to take 27 and multiply it by 9. I'll do that down here below. And I get 243. So 3 to the 5th is 243. 2 to the 9th is not 18. It's not 2 times 9. It means 2 multiplied by itself a total of 9 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now you can multiply them each individually. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, times 2 is 128. Most people don't multiply that very well. They mess up somewhere in the middle. So I would suggest grouping it. Okay? I know that 2 times 2 times 2, 2 times 2 is 4, times 2 is 8. 2 times 2 times 2 is 8 again. And 2 times 2 times 2 is 8 a third time. I know that 8 times 8 is 64, so I basically need to take 64 and multiply it by 8. 64 times 8 is 512. So 2 to the 9th is 512. Okay. You must be careful with multiplying these out because you can make mistakes if you miscount or you don't multiply right. If I would have said 2 times 2 times 2 is 6, which a lot of students do for some silly reason, I would be off massively by the time I got to the end of my problem. So multiply carefully. I would highly suggest doing what I did here, which was to write out all of these so that you make sure you do it the proper number of times. It's not a bad idea to know what it is that you're doing, and so you can keep track of things. The next thing we're going to talk about is order of operations when we add exponents to it. We've talked about order of operation problems before. Before, we didn't have any problems that had any exponents. Now, we're going to add exponential problems to these. So we have to remember the order of operations again. Do all problems within parentheses first, then do all the work with the exponents, then multiply and divide in order from left to right, add and subtract in order from left to right. So let's take a look at a few problems here. If we're going to simplify these expressions, 2 to the third minus 6 divided by 3. According to the order of operations, we have to do 2 to the third first. Okay? 2 to the third is 2 times 2 times 2, which happens to be 8. So I now have 8 minus 6 divided by 3. Order of operations says I need to multiply or divide before I add or subtract, so I have to do the 6 divided by 3. So I'll bring down my 8. 8 minus 6 divided by 3 is 2, and 8 minus 2 is 6. Notice how I show all my steps vertically going down the page and how they're neat and easy to follow. Problem number 8, 5 plus quantity 2 plus 1 squared. Order of operations says do the parentheses first, so we really need to do the 2 plus 1. So that's going to be 5 plus 2 plus 1 is 3 squared. So now I need to do the 3 to the second power, or 3 squared. Okay, 3 to the second power is 3 times 3, which is 9. And 5 plus 9 is 14. Neat, tidy, and well done. Number 9. This one's a little bit harder because it has decimals, multiplication, subtraction, and an exponent all within the same type of problem. Order of operations says I need to do what's in parentheses first, but within my parentheses I have to do order of operations. So be careful. So I have 24 minus, I'm not going to do the 8 minus 1.2, I'm going to do the 1.2 times 5 first. So I'm going to leave that 8, and I'm going to leave that that subtraction sign. And I'm going to do 1.2 times 5, just in case you don't know what that is. Do it off to the side. Okay, 1.2 times 5 is 60. It's actually 6, excuse me. Forgot my decimal point. Okay, so I now have 8 minus 6, but I still have that to the second power, or squared. So according to order of operations, I have to do the 8 minus 6 first. So I'll bring down my 24, I'll bring down my subtraction sign. 8 minus 6 is 2, and that's still to the second power. So now I'll do 24 minus 2 to the second power is 4, so that would be 20. So simplifying and using order of operations with exponents is not difficult. However, you do need to make sure that you're very meticulous and very careful. Don't forget the specific order. Remember, please excuse my dear Aunt Sally. Parentheses, exponents, multiplication and division from left to right, addition and subtraction from left to right. Okay? If you can remember these rules, you'll find that working with exponents is not all that difficult.